Solving inequalities involving absolute values is very similar to equations in that we're going to get one positive and one negative because absolute values will always turn the negative into a positive and keep the positive. So we're always going to get those two answers, one positive, one negative. But when dealing with an inequality, it's slightly different. So let's look and see what it's saying. We already know we're looking for the distance from 0. What we want is all values of x that have a distance from 0 that is greater than 2. So 2, 3 is greater, 4 is greater. So we're getting this situation, every single point, every real number that is greater than 2, not including 2. And then so here's negative 2. Now when you take the absolute value of a negative, it turns it positive. So if we absolute value negative 3, that becomes positive 3. So we get this situation. So if you see they're both going away from 0, which is what you can kind of think of as greater 0. So that's a distance of 2. That's a distance of 2, and we want all the values that are greater than 2. So 3, 4, 5, 2, 3, 4, which gives us this situation. I put infinities on there. We have x is less than negative 2, or x is greater than 2. Those are the two situations. So in interval notation, it would be from negative infinity to 2, and we have to put a parenthesis here because we don't actually equal 2, union from 2 to infinity. So we have to unite our two sets. So there's our interval notation. So this is how we're going to solve it. You're going to take this one and make these two equations out of it. And here's a nice coincidence. We have x is greater than 2. So you just throw the absolute values away and you get that. And then what happens with the negative is the inequality flips. So the way I like to think of it, this isn't true, but if you divide by a negative, what happens to the inequality? It flips. So the negative one flips. It's a nice coincidence. All right? And these are greater. That's how you can remember them as well. Greater. The or statement in between. We're getting two intervals, this one or that one. Okay, let's look at now less than or equal to 4. So there's 0, and there's 4, and we want all the values that are less than 4. I put too many in there. 1, 2, 3. So 1 is less than 4, 2 is less than 4, 3. Everything here is less than 4, including 4. So all the little values in there, even the fractions, decimal, every single real number. And it works the same with negative 4, 2, 3, 4. Every single value in between here would also have a value that is less than 4, 1, 2. So that's a distance of 1 or a distance of 1, distance of 2 or a distance of 2. So if you notice what we're getting with less than is an interval. We get this compound inequality from negative 4 to 4. So x is greater than negative 4, but less than 4. It's all those values in between. And in interval notation, it looks like this. So these are our ands. It's between here and there. It's this or that. That's how you can remember it. This or that between here and here. So if it's less than this, greater, it's that. So let's try them. Okay, greater, either of these symbols, less than any of these symbols. So our absolute value is greater than 7. Greater than 7. So we write x plus 4 is less than or equal to negative 7. So remember, put the negative, flip it, and then we rewrite it exactly how it looks, but throwing away that. And we put an or in between. And these are our two inequalities that we get to solve. So it's the same thing we did up here. We want the less side and the greater than side. So we have the less than 7 and the greater than 7. And we solve it. Sorry, the less than negative 7 or the greater than positive 7. So x is less than negative 11, or x is greater than 3. So putting those on the graph, there's 11 and there's 3, and they're in their respective spots. And so we want less than, and we want greater than. Put a bracket and a bracket. Let's redo that one. And there's our graph. So our solution set in interval notation, let's put our negative infinity, infinity, would be from negative infinity to negative 11, bracket, union, 3 to infinity. And that's it. That's what we get for solving our absolute value is greater. Now let's look at the less. So it would be the same thing, but in this case, we do a compound inequality. We put the negative on the left because that's where negatives go. We put the positive on the right because that's where positives go. And then we solve. And there's our two values that our x is in between. So we put negative 11. We put 3. Shade in between. And since it's equal on both, we put a bracket on both. And then we write our interval. So there is our greater than, and there is our less than. And that's what you should be getting. Okay, these are two special ones now. If I can get them to go. There we go. Okay. So, in order to solve these, it's the same thing we did with the absolute value equations. We had to isolate it. So you have to do the same thing there. This needs to be isolated, which means we need to get rid of the 3. And divide by the negative to get our absolute value all by itself. Now when you divide by a negative, make sure you flip the inequality. I'm going to write it in green so we know it's flipped. Because of these two little guys right here. We're dividing by a negative, we have to flip it. Alright, now it's a greater than. So we go 2x minus 5 is less than negative 2, or 2x minus 5 is greater than 2. So exactly how it looks without the absolute value. And in the negative one, we have to flip it. So solving it, I'm going to do this one a little quicker. So plus 5 is 3. That's 3/2. Now let's see what the other one is. Okay, this one's 1.5, and this one's 3.5. So 1.5 and 3.5. And we want less that way with a parenthesis, and greater this way with a parenthesis. The parenthesis is not really on where I need it to be. Right there. There we go. So interval again would be from negative infinity to 1.5, parenthesis, union 3.5 to infinity. And there's our answer. Okay, now let's look at this one. This is the and. So when we subtract the 3, divide by the negative 1, we get an and statement. Okay? So that would be from negative 2 to 2. Remember, we want the things that are less than here. So what's in between them? The distance has to be less. Add the 5. Divide by 2. So you notice exactly the same numbers. But our difference here now is we want the area in between them with a parenthesis. And there we go. So interval would be 1.5 to 3.5. And that's our answer. So if it's and less than, you're getting the areas that are in between. We want the values of x that are less than that value. So what's in between them? And greater, then we want it to go out. We want greater values. And that's it. Thank you.